This is a walkthrough of Problem 2 on Exam 1 of Module 3 from the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 2, a force table used by physics students to learn how to add forces. There's a center metal ring with some ropes tied to it and some forces exerted on the ropes. We have a 30 Newton force horizontally in the diagram and a 50 Newton force 30 degrees to the left of the negative y-axis. What force will balance the other two? Let's guess. What do you think? If a 30 Newton force is here and a 50 Newton force is here, you want to balance them. Where are you going to put that third force, and how big is it? I'm going to guess something like that. Let's call this force vector F. And we'll call the angle it makes with the negative x-axis theta. We have to calculate the magnitude and direction of that vector. Let's define the x-axis as horizontal. In the x direction, we have 30 newtons to the right, and we have 50 newtons backwards, and we have sum of F backwards, if we guessed right. Sum of the forces in the x direction is ma sub x, and there's the equation, 30 newtons positive, 50 newtons sine 30, that's the opposite side. And I'm just going to write the horizontal component of the F vector as F sub x. This is going to make it easier. If you plug in F cosine theta for F sub x, you got the right answer, but you also have two unknowns. And this makes the math simpler because we have one equation and one unknown. Once we get F sub x and F sub y, we can get the magnitude and direction with the Pythagorean theorem and the arctangent function. So we have F sub x from the x direction. Now we look at the y direction. Sum of the forces in the y direction is ma sub y, and that's 0. And this is even easier than the x direction. Upward force is F sub y. The downward force is 50 newtons cosine 30 degrees. And those balance, so F sub y must be 43.3 newtons. The magnitude of the force needed is the x component squared plus the y component squared. Take the square root of that, and we get 43.6 newtons. So that's the length of the vector, the magnitude of the vector. Now we need the angle. Tangent is opposite over adjacent. Here's our theta. The opposite side is the 43.6 newtons, and the adjacent side is the 5 newtons. And we get arctangent of 8.66, which is 83.4 degrees, and that's the answer to the question. The third force is 43.6 newtons at 83.4 degrees above the negative horizontal axis. Now, I really don't like that. That's a lot of math, not a lot of physics. Let's do it again. But first, let's break the vector into the components rather than rely on equations. That's how we started. But first, let's get the components of the 50 Newton force. Horizontally, 50 newtons sine 30, 25 newtons in the negative x direction. Vertically, 50 newtons cosine 30, which is minus 43.3 newtons, 43.3 newtons down. So now I'm going to take that 50 newtons out of there. And the 30-degree angle, I'm just going to put the components in, like that. Now I'm going to take the F and make it F sub x and F sub y. Get rid of the theta. Just going to break up the unknown force. There it is. Now, stare at this diagram and say, what's F sub x so that there's no force in the x direction? What's F sub y so there's no force in the y direction? If there's 30 newtons in the positive direction, that's 25 newtons. F sub x has to be 5 newtons back. If there's 43.3 newtons down, and this force balances that force, F sub y has to be 43.3. Okay, so we know what that is by looking at it. Then we can use the Pythagorean theorem and arctangent to get the magnitude and direction. It gives the same result, of course, but it's a little bit more intuitive, and you're not trusting your ability to solve an equation for a variable. That's problem 2.